Alright, we're on to our last section of Chapter 8, and it's over proportionality theorems. So we're going to go through our three definitions, and we've kind of talked about these before. We have corresponding angles, and corresponding angles are pretty much matching angles. So these are angles in the same relative position in two figures. Those are corresponding angles. The ratio, and that was in our very first part of this unit before we even talked about Chapter 8, is a comparison of two numbers by division. And a proportion are two ratios that are equal. Alright, so those are our three definitions that we're talking about, and we're going to go head to our first theorem, and it's the triangle proportionality theorem. And you see I've already had our example written there. So it says if a line parallel to one side of a triangle intersects the other two sides, it divides the two sides proportionally. And so here's our two of them. So we have two lines in our triangle that are parallel to each other. So Q, S, and TU. So if these are parallel, then RT and RU are similar. And then TQ and US are similar. So that is what this means. And of course, this can be written a number of ways. For example, we'll do this first one. So we want to solve for x. And so I'll give you a minute to draw this here, but how would we solve for x? And note, you can always pause at any time. And so let's look at what would be congruent to x, or in this case, VW. So VW is actually very congruent to WX. And then we know that VZ is going to be congruent to ZY. But VZ will go under VW, and ZY would go under WX. Okay, so now we can plug in our numbers. So VW we said was a variable of x. VZ is 10. And then I have WX, which is 12, all over ZY, which is 8. And I've set up my proportion. I'm going to use butterfly or cross multiply. So I have 8x equal to 12 times 10. And 12 times 10 is 120. I'm going to divide by 8 on both sides. So x equals 15. Okay, so that's how we set proportion. Note that our two lines are parallel to each other. Okay, so that's showing that these two are congruent and these two bases were congruent. Of course, you can always use this way as well, plugging in numbers. So let's go on to our next one, which is the converse. So now it says if these two are proportionate to each other, so if my parallel, if RT is congruent to, or if it's with QT or TQ, then my two lines are parallel this time. Only if it's proportionate. Okay, so let's do this example this time. We're still solving for x. So it's very similar to the first one we did, we're just having more practice. So let's solve for x. So there's two ways of doing this one. So we have RQ, and it is congruent to QU. That's another way of looking at this. And under RQ, you can have RS, because it is part of the what looks like the smaller triangle. And then under Q, you would have ST. The other way you can put this is RQ all over QU. So even though these are congruent, you can also put them underneath each other. And then RS all over ST. So this is two ways that you can actually do this problem based on this. And so I'm left with RQ, or whatever X is, all over 4. And QU is 9, and ST is 6. And again, if you wanted to put it this way, you still end up with 9 on the bottom, and then 4 over 6 this time. Yet, when I cross multiply, I use butterfly on each of these, I still have 6 times RQ equal to 36. And then when I divide by 6, RQ gives me 6. So this is 6. Okay, so those are two examples on proportionality theorems. And we're going to go on to our next page. Note you can always pause at any moment. So this time I have the 3 parallel lines theorem. So we talked about parallel lines and their transversals. Now we just have a whole bunch of them. So I have 3 parallel lines theorem. If 3 parallel lines intersect 2 transversals, so I have 3 parallel lines here and 2 transversals, then they divide the transversals proportionally. So in this case, it says that UW is very similar to WY, and then it says VX is very similar to XZ. And I'll put double here so you can see that. So this is showing that if you were lines on the road, that these two would be congruent and these two would be congruent, or similar to each other. So we have an example here, and I want to find EF. That's where X is labeled. I want to find EF. I have DE is 35, AB is 30, and then BC is 12. Okay, so setting up my proportion, I'm going to talk about AB. So AB in this case is congruent to BC, and DE is congruent to, you guessed it, EF. And I just blocked it by sides. And so I can plug in my numbers. So I have 30 all over BC, which is 12, which is equal to 35 over EF, or you can put X. That's what we're looking for. And now I can cross multiply or use butterfly effect. So I have 30 times EF equal to 35 times 12, and 35 times 12 is 420. So I'm going to divide by 30 on both sides. EF gives me 14. Okay, note there's more than one way to actually set up this proportion. I could do AB is equal to BC, and then DE and EF. So you can still have very similar to what I've done on the first page. If this way works best for you, by all means you can use this way, or you can use the other way by comparing AB to DE this way. So, okay? Alrighty. Let's go on to our next one, the triangle angle bisector theorem. And so this one, it says if a ray bisects a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths on the other two sides. It's kind of confusing, but that's why we have examples. And so for this example, we want to find RS. We want to find this part, RS, what X could be. Okay? And so let's set up our proportion. So in this case, it says AD comes very similar to DB. That's why they have an overlap like a scale factor. And then CA will be equal to CB. Okay, so that's how they're dividing this up. So we can do the same thing here. So what is congruent to RQ? So we're looking at RQ here. What's congruent to RQ is RS. So I'm actually going to put it on the bottom like it shows me here. And then RQ's partner is PQ. and RS's partner is PS. Okay, so now I can plug in my variables. However, note, if we want to find a certain part, we have to subtract to find the missing angle, to find the missing side. And so, I have RQ is really all of 15 subtracted from our X. So this top part is really 15 minus X all over X, which is here what we're trying to find. And then we have 7 over 13. Okay, so now I'm going to cross multiply.
Plus 400 is here for the swim team. Plus 400 is here in the back for the swim team.
Please pardon that interruption. I cannot control when the announcements come on. So, moving on, I have 15 minus X, and then all over X, and 7 all over 13. I'm going to use the butterfly effect to multiply. Note, you have to use parentheses. Okay. So, when I distribute, I am left with 195 minus 13x equals 7x. Going to add 13 to both sides. So I have 195 equal to 7 plus 13. So it's 20x. And then I'm going to divide by 20 on both sides. And x gives me 9.75. Okay? So the big part about this, if we want to find RQ, is that 15 minus the X part. So remember when we took number lines, the whole thing was 24, and this part was 10, how would I find the other side? Remember, I would subtract. So I would take 24 minus 10 in order to get this missing part. So that's just a short review on how we would get that. Okay, so now we're on to our extra practices. So exercise 1 and 2 says find the length of AB. So we're trying to find this part. So I'm going to have AB would be equal to some sort of proportion. So I have AB is congruent to AE. And then what's partnered with it is BC, and what's partnered with AE is ED. So I have AB is blank, I'm not sure what it is yet. AE is 5, BC is 6, and ED is 10. Okay, so I've set up my proportion. I'm going to cross multiply. So I have 10 times AB equal to 30. I'm going to divide by 10. AB is 3. Okay, so moving on to the second one. So we're trying to find AB. And AB is congruent to which side? I'd say it'd be AC. Or I can say AE. But I have no other way of knowing that. But it's going to be congruent to this side, so BC. And then what's partnered with that, with AB, would be ED. And with BC would be DC. So AB is blank, we're not sure what it is yet. BC is 7. What goes under AB is partnered, so it would be 2. And then DC is 9. Okay, I'm going to cross multiply, so I have 9 times AB equal to 14. I'm going to divide by 9 on both sides. And AB is 14 over 9. There's no way of simplifying that. Or you can use a decimal. So 14 over 9 is AB. Going to the next page. Let's see if we can do these together. So it says determine whether AB is parallel to XY. And for these, I'm going to have you work backwards. So for number 3, the answer is no. Tell me why. And for number 4, the answer is yes. Explain to me why. Are these proportionate to each other? So, would 3 over 4 match 4 over 5? Probably not. And these two, always check to see if they're proportionate. And if they are proportionate, that means these lines are parallel. So, this is your work. Tell me why. Okay? So number 5, 6, and 7, we're using the diagram to complete the proportions. This is UV, so this part is congruent to XY. So what would be congruent to UW? So what would be congruent to UW? Well, UW would be XV. That would be going to the bottom. This one says XY is congruent to whatever blank. So I have XY is here. And then the bottom says YZ is congruent to VW. Well, we kind of already know this one because it gave it to us. So UV for number 5. And then number 7, we have ZY. So ZY is here, is congruent to WV. Now what's congruent to WU? Well, we kind of already saw that one. It would be XZ. Alright. And then our last two, trying to find the value of the variable. So in this one, we have to set up our proportion. So we have what would be very similar to 15, be 9, x would go underneath, and 5 would go underneath. So we cross multiply, so I have 15 times 5, which is not 45. Oops. Apparently I made a mistake, and that is okay to make mistakes. It's okay to make mistakes. You always can check your answers. You're definitely not 45 just yet. So let's say I had 15. Oh, pardon 1 second, I have someone at the door. Okay, so I have 15 on top, and it's going to be congruent to 9. And then what goes with the 15 would be 5, and the bottom part would be x. And so I have 15x equal to 45. That's what 9 times 5 is. And divide by 15, x equals 3. Now, remember this one's a little tricky. In this one, you have b, I'm going to give you the answer, is 8. So how would I set up this proportion? So remember, if I want to find one part, I would have to take 14 minus b. I just want this part. Okay? So that concludes our 8.4 notes. And see if you can try to figure out number 9. Thank you so much.